Prepare for a journey to the edge of our solar system. Far beyond the familiar planets, a lonely world emerges. Mysterious, icy, and unlike any world we've known. Pluto, a complex and active world, colder than you can imagine, with landscapes that defy expectation. Rivers of nitrogen ice. Our first stop is a vast expanse of frozen plains. Here, immense rivers of solid nitrogen have carved paths through the terrain over millions of years, flowing like glaciers on Earth. This isn't a static dead world. The slow, powerful movement of this nitrogen ice is a sign of ongoing geological processes, reshaping the face of Pluto. In the distance, dark and rugged highlands punctuate the horizon. The ancient cratered terrain of Viking Terra, standing in stark contrast to the younger plains. We are seeing the edges of the vast, dark Cthulhu Macula, a feature stretching nearly halfway around Pluto's equator. Its reddish color is thought to be from complex organic molecules called tholins. Look around you. Under the faint light of a sun, billions of miles away, you are witnessing a landscape that blends the familiar concept of rivers with the exotic nature of a world built from ice. Pluto's glaciers. Now we get a closer look at Pluto's glaciers. Unlike Earth's glaciers of water ice, these are made of frozen nitrogen, methane, and carbon monoxide. These exotic glaciers are in constant slow motion, flowing out of mountainous highlands and carving valleys as they creep across the surface, a process that has been happening for eons. Pluto's bladed terrain. We now travel to one of Pluto's most alien landscapes, the bladed terrain. Here, towering spires of methane ice, some as tall as skyscrapers, claw at the thin sky. These incredible formations are found at the highest altitudes on Pluto. This specific region, with its countless sharp ridges, is known informally as Serpens sulci. Scientists believe these blades form as methane ice freezes out of the atmosphere at high elevations. Later, as the climate shifts, the ice erodes, leaving these dramatic crests behind. This process is similar to how penitents form in high-altitude snowfields on Earth, but on a gargantuan scale, with blades rising hundreds of feet. Take a moment to absorb this forest of ice, a landscape sculpted by a unique atmospheric cycle, on a world almost beyond our reach. Pluto's volcanoes. Prepare to witness another of Pluto's startling discoveries. Ice volcanoes. These colossal structures, known as cryovolcanoes, suggest a warmer interior than once thought. Instead of spewing molten rock, these volcanoes erupt a slushy, icy mix of substances like water, nitrogen, and ammonia from beneath the surface. We're now approaching Wright Mons, a massive cryovolcano about 93 miles wide and 2.5 miles high, with a deep depression at its summit. Notice the strange, lumpy texture on the mountain's flanks. This may be the result of icy lava flows that have oozed down from the summit. Nearby stands the even larger Piccard Mons, another giant ice volcano. The existence of these massive structures points to relatively recent geologic activity within the last 1 to 2 billion years. The presence of these cryovolcanoes challenges our understanding of how small, cold worlds can generate and retain enough internal heat to power such dramatic geologic events. Looking at these immense, silent giants, We are reminded that even in the coldest reaches of our solar system, worlds can be surprisingly active. Sputnik Planitia. We now descend into Sputnik Planitia, the vast, craterless western lobe of Pluto's famous heart. This enormous basin is filled with soft nitrogen ice. The surface here is broken into large, irregular polygons. These are the tops of convection cells, where warmer ice from below slowly rises and cooler surface ice sinks. This constant churning motion means the surface is geologically young, estimated to be less than 10 million years old. Look for the narrow troughs that mark the boundaries of these cells. This process of sublimation in convection is fueled by the faint warmth of the sun, creating a dynamic surface that resembles a giant, slowly bubbling cosmic lava lamp. Mountains of Cthulhu Macula. We are now over the Cthulhu Macula, a long, dark region stretching across the equator. The dark reddish color is likely due to organic compounds called tholins. Rising from this dark expanse are enormous mountains, but these are not mountains of rock. They are mountains of incredibly hard water ice, forming Pluto's bedrock. Many of these mountain peaks are capped with bright frosts of methane ice, creating a stunning resemblance to snow-capped mountain chains on Earth. Pluto's geysers. The frozen plains of Pluto are not as tranquil as they appear. A sudden tremor might be the only warning before the surface shatters. From a newly formed fissure, a violent plume erupts, not of hot steam, but of supercooled nitrogen gas escaping its subsurface prison. This powerful jet, laden with dark dust, soars high into Pluto's thin atmosphere. This incredible display is thought to be powered by sunlight penetrating the translucent ice, warming the nitrogen below until it vaporizes and bursts forth. Against the blackness of space, the plume rises like a dark fountain in slow motion. It hangs suspended for a moment, a ghostly temporary monument born of immense pressure and faint sunlight. As the erupted material gracefully descends, the faint atmosphere carries the dark particles, painting long, dark streaks across the bright canvas of ice. It is a stunning, direct observation of how this active world is constantly reshaping its own surface. Ice plains. We now return for a final look at Pluto's most iconic feature, its heart, officially known as Tomball Regio. This massive, bright heart is a colossal reservoir of nitrogen ice. Its left lobe is the smooth, convecting Sputnik Planitia, while the right lobe is made of highlands coated in nitrogen ice. This heart isn't just a surface feature. It drives Pluto's entire atmosphere. Daily cycles of nitrogen ice sublimating into vapor and recondensing as ice create powerful, planet-circling winds. As we depart this distant world, we leave with a new appreciation for its complexity. Pluto has shown us that even the coldest, most remote corners of our solar system can be geologically alive.